So when you're doing the first page, you are really just following what it tells you to do. It's basically, think of it as order of operations for matrices, okay? So like if you have a number on the outside, you're just distributing it through. If it wants you to add, you have to have the same dimensions, but really you're just adding your like or corresponding elements rather. So this part, most of y'all did really well on this on your quiz. If you're distributing, you're just going to multiply each piece by it. And so I didn't really see any problems. Just watch your positives and negatives. Same thing with something like number 2. Addition's fine. Subtraction's where most people run into problems. So like if you look at number 3 and 4 on your quiz review or test review, pay attention to those positives and negatives. But other than that, you're really just corresponding elements. You're either adding or subtracting, whatever it's telling you to do. And that would be your final answer. Matrix multiplication was the more difficult of the things that you had on your quiz. And so remember, it is row by column. So you do want to make sure that you can do it. So if I have something like this is a 2 by 2, and this guy is a 2 by 3. That means, yes, I can do it, and my answer will be a 2 by 3. Okay, so I should expect to have 2 rows and 3 columns on my answer, all right? And so to do your matrix multiplication, remember you're going to start with your first row and multiply by your first column. And so I'm going to say 3 times 1 plus negative 6 times negative 5. And that is my first one. Then I'm going to go on to my next one. 3 times negative 6 plus negative 6 times negative 5. Then go on to the third one. And I'm going to say 3 times 4 plus negative 6 times 0. And I am done with my first row. We're going to do the same thing with the next row. So I will start with this row and go to the first column, and I will say 3 times 1 plus 2 times negative 5. 3 times negative 6 plus 2 times negative 5. And then 3 times 4 plus 2 times 0. All right. And then you're just going to do the multiplication and addition. So I would have a 3 plus 30 here. That would mean that my first element would be 33. I have negative 18 plus 30. So I'm going to have a 12. And then I have 12 plus 0. That's going to give me 12. So that's my first row. Then I'm going to have 3 plus negative 10, negative 18 plus negative 10, and another 12 plus 0. And so this is my answer. It is a 2 by 3, as you can see. And so I know that I at least got my dimensions right there. So the inner tells you, can you do it? The outer tells you, what is my answer going to be? This was really just solving equations. And so I want you to think of this as a number minus 4x equals a number. What would I do? I would subtract the number over, then I would divide by negative 4. That's what I would do. And so that's all you're doing for this. You are going to subtract this matrix here because it is a positive. And so you're going to take that matrix and you're going to subtract it over here, just like you would if you were doing an equation. You would subtract it. On the left-hand side, you're left with a negative 4x. And on the right-hand side, it's whatever happens when you subtract. You are subtracting, though. So negative 5 minus a 3. So you have to think about your rules of addition and subtraction here so that you get the right answers. 31 minus a negative 5. Well, that's going to be plus a 5, right? Negative 18 minus 2. And then negative 16 minus 8. And now that I've done my subtraction, I am going to divide by negative 4. Remember, scalar multiplication is the same thing as division, right? Dividing by -4 is the same thing as multiplying by 1/4. So I can divide every single piece by -4 as well. And so my x is going to be what happens when I divide each of these by -4. -8 divided by -4 is +2. 36 divided by -4 is -9. -20 divided by -4 is 5. -24 divided by -4 is 6. And that would be my answer to this equation here. All right, so 2 by 2s are really simple if you will just remember it as subtraction. That's like the biggest problem is when people run into negatives, they forget they're subtracting. So I am multiplying the first diagonal. So I would say 1 times 0 minus what happens when I multiply my second diagonal, 4 times -5. So I have 0 minus a -20. My answer here is +20. The biggest mistake I would see on a test or quiz would be I would get the positive and negative wrong there. Okay, so just really pay attention to you are always subtracting, and whatever happens with multiplication is the rules of multiplication, then you apply your rules of subtraction. You are welcome to do it whichever way you want to do it. If you want to do your diagonals, then you're going to want to shift this over so that you can create those diagonals. And remember, you are just multiplying down. So my first group is going to be -2 times -1 times 1 plus my next diagonal, -5 times 1 times -2 plus my final diagonal, which is 4 times 0 times 0. And then I am going to subtract, right? We're subtracting. And we're going to go the other direction. We will say -2 times -1 times 4 plus, you're still adding inside of it, 0 times 1 times -2 plus 1 times 0 times -5. All right. And so when you do this, you're just going to simplify within. So I have -2 times -1 times 1, -5 times 1 times -2, and then plus 0. We have -2, -1, and 4, 0, and 0. So I end up with 12 minus 8. My determinant here is 4. All right. If you wanted to do it the other way, you could use this column and do 2 by 2s. So you're welcome to do it with 2 by 2s. You would just say -2 times the 2 by 2 that's left over. You have a 0 here, so that doesn't matter. And then plus a -2 times the top 2 by 2 that's left over. You can do it that way as well. So you're going to get the same answer whichever way you do your 3 by 3s. So if I want to use Kramer's rule, I'm going to do a 2 by 2 for my coefficients. So I'm going to do a 2 by 2 using just my coefficients. That's going to be one determinant. I'm going to do a 2 by 2 for my x. And remember, x is your first column. And then leave your y column alone. And then, of course, you're going to do a y determinant for your y column. All right. And you just do exactly the same. 2 times 4 is 8 minus 2 times 2, which is 4. So my determinant here is 4. 15 times 4, we have 60 minus a -28. We have 88 here. And then for this one, we have -28 minus 30, we have -58. To find my x value, I'm going to take the 88 here divided by the 4. To find my y value, I'm going to take the -58 divided by the 4. Leave it as a fraction, that's fine. So my answer here would look like this. All right. Now remember, the rules for finding an inverse is to find the determinant, put 1 over the determinant, and then multiply it by your really crazy switched and negated diagonals, okay? So first thing I'm going to do here then is to find this determinant. So my determinant is going to be negative 4 times 5 minus 0 times 10. So I get negative 20 as my determinant, right? Then I am going to say 1 over negative 20. And I am going to switch my first column. So I'm going to make the 5 up in the top left, the negative 4 in the bottom right. And then I am going to negate the other column. 0 does not negate, so we don't have to do anything there. 10 is positive, so I will make him negative. By negate, I just mean change the sign of that second diagonal. Whatever the sign is, make it the opposite. And then you are really just multiplying through. So my inverse here, negative 5 over 20, negative 10 over negative 20, 0 over negative 20, and negative 4 over negative 20. And of course, I do not want you to leave it that way. I do want you to reduce, so your final answer here is going to be negative 1/4, positive 1/2, 0, and then positive 1/5. I do want you to leave it as fractions. I do not want you to give me decimals there. Just leave it as a fraction. Using inverses. So when it says solve using an inverse, you find the matrix that is with your variable. That is the inverse you're going to use, okay? Don't take the inverse of the other guy. You want the inverse of the one that is with the x. So I'm going to do the same process here that I did up there first. I'm going to find my inverse. So I need to, for this matrix right here, let me just move that one. I'm going to find my determinant. So I'm going to say 6 times 7 minus negative 6 times negative 8. So I have 42 minus 48. I get negative 6. All right. Once I have that, I'm still finding my inverse. So negative 1/6 times the little switch these, negate these. All right. So my inverse is going to be negative 7/6, negative 8/6, negative 6 over 6, and negative 6 over 6. All right. I will say one thing. You can reduce like the ones, but you may actually want to leave that 8/6 alone. I know that sounds weird, but unless it cancels out perfectly, you already have a common denominator because you're going to be multiplying through and then adding. And so if you already leave it as a 6, now the ones are both ones and those are on the same row. So if you have a 1 and like whole numbers on a row, then let them be whole numbers. But if you have fractions that won't reduce to a whole number, leave them as that denominator. So I'm saying if I want you to just hand me the inverse, reduce everything. But if you're about to use the inverse to multiply and add, you're going to be multiplying and adding fractions, which will need a common denominator. So why would I reduce my 7/6 cannot reduce. That's on the same row as my 8/6. If I reduce that to 4/3, then when I multiply it through, I'm going to have to multiply it back to get a common denominator, which does not make sense. Now for the second row, I have a -1 and a -1. Well, that's much easier to multiply by, and they both already have a common denominator on that row. So I'm going to reduce that second row, but not the first, for a reason. Like my logical brain is telling me to do this for a reason. So I am now going to take this guy and I'm going to multiply him through to the other side. Like I said, I'm going to leave the -7/6 and the -8/6 alone. I'm going to reduce these to -1 because I am multiplying row by column. Row by column, all right? So I am going to do exactly what I would have done before. I'm going to take this row and multiply it by this column. All right. And so this is where having the common denominator may help a little bit. I'm going to take 7/6 and multiply it by 40. And it will work out, I promise. So I have negative 280 over 6 plus, and then I'm going to multiply the 8 by the 38. They're both negative, so that's going to be a positive 304 over 6. So when you do this, remember you are adding there, right? And then we have a negative 1 times 40 plus your 38 there. All right. Questions on that one? So when you're done here, you want to now add and subtract this, and then get reduce it if possible, really, is what you want to do. So when you add and subtract those, hopefully we will get, so 24 over 6, and then that reduces to 4, and then negative 40 plus 38 reduces to negative 2, and so this is my answer here. So even though the fractions look huge, if you leave your denominators, you're just going to have to multiply your numerators, because your denominators are going to stay the same. You already have common denominators, so you just add or subtract your numerators. And for these, you're going to get whole numbers for me. So when you add or subtract that numerator, it's going to be perfectly divisible then by that denominator, if that makes sense, okay? So if they don't both reduce to whole numbers, leave them as their unreduced fractions with the same denominator. And then all you have to do is multiply your numerators, add or subtract your numerators, and then it will divide evenly for you.